A Carnot engine CE1 works between two temperature reservoirs A and B where TA equal to 900 Kelvin and TB equal to 500 Kelvin. A second Carnot engine CE2 works between temperature reservoirs B and C where TC equal to 300 Kelvin. In each cycle of CE1 and CE2, all the heat rejected by CE1 to reservoir B is used by CE2. For one cycle of operation, if the net Q absorbed by CE1 from reservoir A is 150 megajoule, the net heat rejected to reservoir C by CE2 in megajoule is dash. So before we solve the given numerical, let's understand the statement of the numerical as per the data given. So let's write down the data given here. So it is mentioned that TA equal to 900 Kelvin, TB equal to 500 Kelvin and TC equal to 300 Kelvin. So here, for more clarity, to understand the statement of the numerical, let's draw a diagram of Carnot engine, that is Carnot engine 1 and Carnot engine 2. So as per the question, the Carnot engine 1 receives heat energy from a reservoir, that is a hot reservoir, having temperature 900 Kelvin. So let's say this is a reservoir having temperature 900 Kelvin. So let's say the reservoir is A. And from this reservoir, the heat energy is received by the Carnot engine. And let's say that is QA. And as per the question, it is mentioned that the net Q absorbed by CE from reservoir A is 150 megajoule. So QA is 150 megajoule. So let's write down this QA under data given, that is QA equal to 150 megajoule. Next, after performing some work by Carnot engine 1, the remaining amount of energy, that is heat energy, is rejected to another reservoir having temperature 500 Kelvin. And let's say the reservoir is B. Now, according to the question, there is another Carnot engine, that is CE2, which works between reservoir B and C. So here it is reservoir B. So another reservoir is there, and in between these two reservoirs B and C, the Carnot engine C2 works. So let's consider the Carnot engine CE2, and here in this question it is mentioned that the Carnot engine CE2 receives or use the heat energy which is rejected by Carnot engine 1, and that is the QB. So it means this QB amount of energy is received by the Carnot engine 2 when the same amount of energy is rejected by Carnot engine 1. And after performing some work by Carnot engine 2, the remaining amount of energy is rejected to the reservoir, let's say the reservoir C, and having temperature as per the question Tc equal to 300 Kelvin. So now I think the diagram is clear according to the question. So now the question arises that what we are going to calculate here for the given numerical. So that is the net heat rejected to reservoir C by CE2 in megajoule. So it means the heat rejected by Carnot engine 2, that is QC. So here we have to find out QC equal to this. So now let's approach towards the solution of the numerical. So let's consider the efficiency of the Carnot engine. So first we consider for Carnot engine 1. So for Carnot engine, the efficiency is 1 minus TB by TA. So this is the efficiency of the Carnot engine. So as we know that Carnot engine gives the maximum efficiency. So when we consider the maximum efficiency, we have to consider 1 minus TB by TA. But we know that the efficiency is also calculated in terms of heat energy, that is 1 minus QB by QA. So if we compare these two expressions of equation 1 and 2, so we get 1 minus TB by TA equal to 1 minus QB by QA. And this equation can be written as TB by TA equal to QB by QA. Now let's substitute the magnitude given in the question. TB is given 500, TA is given 900 equal to QB is not given, so just keep as it is. By QA, it is 150 megajoule. So it means QB can be written as 5 by 9 into 150. So now we just keep this expression of QB as it is. And definitely the unit of QB is in megajoule. Now let's consider the efficiency for Carnot engine 2. So let's say efficiency 2 equal to 1 minus TB by, that is 1 minus TC by TB. Or we can also write the efficiency of Carnot engine as 1 minus QC by QB. So if you compare these two expressions, let's say this is 3 and 4, equation 4. So 1 minus TC by TB equal to 1 minus QC by QB. So if we rewrite this expression as TC by TB is equal to QC by QB. Now let's substitute the magnitude of all these parameters. So TC is 300, TB is 500 Kelvin equal to QC that we have to find out as per the question, and QB that already we get the value, that is 5 by 9 into 150. So let's substitute here, that is 5 by 9 into 150. So if we rewrite this expression, that is QC is equal to 3 by 5 into 5 into 150 by 9. So if you solve this one, we get QC as 50 megajoule. So this is the final answer for the given question. Thanks for watching. See you in the next video.